Hello. In this video, we're going to look at how to determine the possible rational roots of a polynomial. So in the last video, we left off with this sneak peek that synthetic division can be used to factor polynomials. Now, in order to do that, we needed to figure out what we're going to divide by. In the last video, it was x minus something. And what we're going to divide by in order to factor are the roots of the polynomial. So this is getting us set up so that we could figure out what to synthetically divide by in order to factor polynomials. So our possible rational roots for some polynomial are plus or minus the factors of a sub 0 divided by the factors of a sub n. And really, sometimes we see it as this, but it's just plus or minus these factors. So for example, if I have x cubed minus 3x squared minus 10x plus 24, this is my a sub 0. The 1 here is my a sub n. So my possible rational roots are the factors of 24. 1, 2, 3, 4. Let's see. 6, 8, 12, 24. Right, so 1 times 24, 2 times 12, 3 times 8, 4 times 6. So these are all of the factors of 24 divided by the factors of 1. Well, that's just 1. So it's all of these combinations. Plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. This is a lot. In the next video, we'll figure out how to narrow these down so that we can pick the right numbers in order to synthetically divide. But for now, these are all of the possibilities. So let's try the next one. We have a sub naught are 15 and a sub n are 2. So the factors of 15 are 1, 3, 5, and 15. The factors of 2 are 1 and 2. So we can see why they call these the possible rational roots, because now we're going to start getting some fractions. And we need to do every single combination. So 1 divided by 1, which is just 1. We want to make sure we have our plus or minus. 3 divided by 1, which is just 3. 5 divided by 1, which is just 5. 15 divided by 1, which is just 15. Now we'll go through the list again with 2. 1 divided by 2, 1/2. 3 divided by 2, 3/2. 5 divided by 2, 5/2. And 15 divided by 2. These would be all of our possibilities. These would be the numbers we try to synthetically divide by in order to factor the polynomial. So let's do one more example. A sub 0, a sub n. So the factors of 6 are 1, 2, 3, and 6. The factors of 8 are 1, 2, 4, and 8. And you can see here, we're going to have a lot now. And how I like to keep this organized is I'll go through my numerators, each denominator at a time. So I'll do 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. Now I'll switch to the next one. This is 1 divided by 2. 2 divided by 2. We'll deal with this in a moment. We'll just go ahead and get them all written down first. All of the combinations. So now we'll divide by 4. And finally, we'll divide everything by 8. So you can see here as I'm writing, there are a lot of combinations this time. But some of these are repeats. Like 2 divided by 2 is 1, and I already listed 1. 6 divided by 2 is 3, and I've already listed 3. So we can continue to go through in order. 1/4 is new, but 2/4 can be reduced to 1/2, which I already have. 3/4 is new. 6/4 is the same thing as 3/2, which I already have. 1/8 is new. 2/8 is 1/4, which we already have. 3/8 is new. And finally, we see 3/4, which we already have. So we can cancel that one out. So if we're just listing our possibilities, we have 1, 2, 3, 6, 1/2, 3/2, 1/4, 3/4, 1/8, and 3/8. So we were able to reduce our list a little bit from the redundancies, but still not too much. But this is our idea for finding the possibilities. Now, we can already tell all of these cannot possibly be the roots. At most, we have a number of roots equal to the degree. So number of actual roots has to be less than or equal to the degree of the polynomial. Right, so we could have some repeats, which is what's taking care of this. Or we could have imaginary roots, which we wouldn't say are actual roots, or at least they aren't real roots. So in the next video, we'll look at how to choose between all of these possibilities to get to the actual